So on behalf of ICIQ, I wish everybody a welcome again, and let's get started. So in principle, Blender is an open source software, which is used for photorealistic or stylized rendering of objects. So in principle, it works like in nature. You have a camera, you have a source of light, and you have a subject. In this part of this tutorial, the subject will be a chemical structure. So let's start from there. To generate a chemical structure, we will use Avogadro, which is also a free program, a hint that I got from Sergio. So this will make us, this will allow us to create a molecule which is chemically correct or correct enough to be shown in pictures. So to do this, we can just draw something. Let's say something relatively simple. Let's say I believe this is a styrene, right? So within Avogadro, it's just click and drag to draw atoms. It's quite common, a common interface. So we can also perform an energy optimization, clicking here and then pressing start. And Avogadro then gives us a very reasonable molecule as a starting point. We can stop this classical field optimization and save the molecule as a PDB. And that will be our subject for the rendering. So let's save it on the desktop. Let's make a new folder. And let's call it Blender for Science. And let's call the molecule. So now we have our subject. Now let's go into Blender, which will provide us other things that we need for creating an image. So this is the general interface of Blender. This is the first thing that you see is this greeting screen. You can escape out of that, and then you can see the contents of your screen in this part here, the contents of your scene. So you have a camera, you have a cube, which is in this case the subject. We will be replacing that with a molecule, and you have a light. So in principle, you have everything that you need. And you can see this part here. This is a 3D view. It is just a representation of where these elements are distributed in space. Okay, so first thing we can do is set up the relative positions of our subject, light, and object. So in order to do this, in order to navigate this window here, we can use this circle here, which allows us to rotate the space if we click and hold. To look at it from a perfect perspective, we can just click, for example, on the Z, and we will get a Z axis view. Another thing that we can do, and which is useful, is to click on this arrow here and get this menu. This menu shows the position of the selected item. So in this case, if we select the camera, we can move the camera by changing the value of its properties. So with this, I already prepared some presets which will work nice in our example. So let's say the camera is at 0, -30, and 0. If you zoom out, you can see it here. And also, I will switch on one additional feature so you can see what I'm pressing or clicking. I did it by using this add-on, which you will maybe not have in your case, but it will not be important. So going back to the camera, I put it to 0, -30, 0, and I will set the rotation to be 90 and 0. So if we want to change the view in the viewport, we can either move this here, press one of the axes for a perfect view, or press the camera button here. If you press the camera button, you will see what the camera sees. Okay, so let's try to render the scene to see how it looks. To render, what is happening is that the camera is calculating using a classical optics formalism what happens when the subject interacts with the light. So the light is basically emitting lines of light, rays, and the rays are bouncing off the subject and going into the camera. And we can render by pressing F12. So when we press F12, we get this thing here. Not very visual appealing, not what we want to do. Okay, so let's try to adjust the render settings to make the subject better focused in the center of our image. So when we have the camera selected, you notice that there is another sub menu here. Let's try to, and you see that there is a camera tab here. So for example, so we have the camera selected, and keep your eyes here. And I will change the selection to the light. So you see, you get a light bulb here with the light selected, but the camera when the camera is selected. So this tab here opens the camera specific options. Okay, so in order to adjust the camera works as a normal camera. So if people are familiar with photography, they will be able to use their knowledge. One thing that we can adjust on the camera is the focal length. So to zoom in, we need to increase this number. So let's put it to about 8. That should be that should look quite nice. Okay, so the camera is now zoomed in, looking at the correct place, and let's make the size of this frame square. To do this, we can click here and set the resolution to 1024 with 1024. Now we have a square window, and this is the scaling factor of the output resolution. More resolution equals more render time. So in order not to punish my computer too much, while we are doing this tutorial, I'll put this to 50%. Okay, so, and another very important thing is the selection here in this tab here is the selection of the render engine. Blender has a couple of different render engines that you can use, but we will be using Cycles, which is basically the best one. So let's try to render again. We expect to see more or less the same thing that we saw before. Okay. The settings, the basic settings of the scene are improving. Okay, so let's adjust the size, position, and intensity of the light. Let's start with the position. So let's say 10 by X, 10 by, or minus 20 by Y, minus 20 by Y, and 10 by Z. Okay. And come to the light tab here. Guys, if you want to communicate between yourselves, could you please mute your microphones? Okay, so now the light is in a better position, so let's try to render again. Okay, we are getting a lighter box, but we still need to increase the power. Again, a preset that I checked before is 20,000 watts should work fine. And let's put the size here to 5. Okay, now we're getting a much brighter box. Okay, so now we finished one part of the scene. That is the camera. We finished also the light. So now let's replace the subject with the molecule that we made before. So in order to delete this box, we can just press X or delete. And we can do the following. So in order to import a protein database file, which we saved before from Avogadro, we need to enable an add-on, which is called Atomic Blender. You can see it, you can find it here. Normally, the first time you open Blender, it's unchecked, but when you check it, then you should be able to do the following, namely to go to File, Import, PDB, and then navigate to the place where you put the PDB file. For me, it should be Okay. Let's say test blender. Let's use this molecule PDB. It should be the same one. Okay. So now we have the vinyl chloride molecule imported into the scene. Not the vinyl chloride, the styrene. But if we look at it from a camera view, it is not well aligned. In order to align it properly with the camera, we can use these tools here on the left side of the page. One is the rotate tool. So as you can see, now we get these curves here, which you can drag in order to rotate the molecule. That is one way to do it. Control Z works to undo, but another way to rotate things is to use R. Press R. You can rotate with respect to your perspective, that you're looking at the thing that you're rotating. But you can also press rotate and the axis. So for example, in this case, it will be RX. You can see you can adjust the position. Cool. Okay, nice. Let's try to render this now to see how it looks. Pretty nice. Not too bad. To make this image more useful, you can see that you have now in the rendered image you have a gray background. And normally, if you want to combine multiple images, it would be nice to have this background transparent. To change this, you need to go to this settings tab here and go to the sub tab, which is called film. And this film has a tick box, which is called transparent. And that makes the background transparent. So if we render it again, you'll see that the gray background has been replaced with the alpha layer. Nice. Okay, next thing, the gray balls are quite large. We should try to change this to make them smaller. In order to do that, let's analyze what we have in the scene again. So in the beginning, we had a camera, light, and a cube. We deleted the cube and did this import PDB. This import PDB, well, it's a script in principle, made this collection here. When we expand the collection, we can see we have carbon, we have hydrogen. If we go to carbon and go to carbon mesh, and then go to carbon ball, we will get properties. We will gain access to changing the size and position of these features of carbon, which is a ball. So let's say carbon is 0.5, 0.5, 0.5. In X, Y, and Z, the scaling should be 0.5. So this is a way how to change the size of the sticks and balls involved in the scene. Okay, so again, we can press F12 to render. Cool, fine. If we want to, so now we know how to align things in the scene, how to resize things in the scene. Now we can go into adjusting the color and the material of the carbon balls and sticks. In order to do so, we need to adjust a bit our screen. So we can grab and hold this border between two sub windows. And let's change this sub window from a timeline to a shader editor. So now that we have the shader editor and we have the carbon ball selected, we can adjust the material of the carbon ball. So now the name of the material is called carbon. Let's leave it as that. And let's just click use nodes. So now these nodes here, are basically a way that Blender handles different types of materials. You see, for the time being, we will just be adjusting this base color. So if we click on base color, you will see you get this color wheel that you can adjust to whatever you like. So we do this by using a shader node. So here in this window, you can see you have a material output to the surface, and we have the carbon ball selected here. So to the surface. So this node here is passing something to the surface of the carbon ball. And it's passing a physically correct material as far as Blender is concerned. But the thing that we were talking about is that we cannot see any changes even though we're changing the color, right? Here. That is because in this viewport view, Blender is doing the minimal amount of work needed that you can arrange stuff around in the scene, but trying not to crash your computer. So you're trying to be computationally cheap. We can go to the full rendered view by selecting this box here. So once we click this, you will see that we turned our carbons into purple. Now, by adjusting the colors here, you can adjust the color of Blender. So let's put carbon to something nice, or not nice, doesn't really matter. Let's put it to orange. Why not? By the way, fun fact: brown in computers there is no brown, as you can see in this wheel. To get brown, you just put things to orange and reduce the value of the color. In principle, whenever you're in doubt selecting a color, a good way to do things is to select a general color direction. If you want things to be red, you select a red color, and then you reduce the saturation, which makes it more similar to gray. You reduce the saturation and then play a little bit with the value, which is the lightness or darkness of a thing. So if you want to make nice modern colors, typically you select a general color, then reduce the saturation and play with the lighting till you get something that you like. Okay, so this looks fine. Let's press F12 to render. So this finished quite fast. The molecule looks quite nice. So let's save it as an image. So let's say image, save as, and let's put it here in, this is here. And let's put it in Blender for Science, this folder, and save image. Okay, now what we will do is go into this part of the scene, left click on the molecule, press right click on the molecule, and say delete hierarchy. That will remove the molecule from the scene. Okay, now we have an empty scene, and now let's try to save this Blender file. And let's save it as, let's call it scene.blend. Scene.blend, and let's say save. Okay, now let's close Blender. So once Blender is closed, all of our settings are still preserved in the blend file. So if we open Blender again, by clicking on the shortcut to Blender, we get this screen here. But inside of this Blender file that we created, this one here, the scene.blend, we have Blender opened, and we have all of our settings saved, as you can see, as we adjusted it here. Okay, so in addition to protein database files that we were using before, we can also import different types of files. One of these different types of files is XYZ. So let's go to File, Import, XYZ, and let's select XYZ file. I have one preferred as well, which is here. It is a nanoparticle of gold. So let's import this. Okay, so now again, the nanoparticle appears. In order to adjust the size and appearance and all of these things of the nanoparticle, we can press S to scale, and then just move the cursor to scale the nanoparticle. We can press G to move it around. And as I said before, you can use rotate to rotate it. All of these commands work in combination with, for example, if you want to rotate around Z, you can press R, Z, rotate around Z. Grab G, X, move it along with X. Okay, but let's say this is fine for the time being. So let's see how this nanoparticle looks when it's rendered. Okay, not too bad, right? We have the 1-1-1 face. We can see it quite nicely. The shadows are quite soft, which is also visually appealing. But in principle, this bottom part of the nanoparticle looks a little bit dull. The shadows look a little bit dull. It looks fine, but we can make it more interesting. In order to do this, and probably you noticed, but whenever I'm pressing something on my keyboard, you can see the keys that I'm pressing in this part of the screen. For example, you can see it here. You see the R? Yes. Okay. So if you have an alphanumerical keyboard with a separated numerical part, you can use the numbers in the numerical part to navigate the window. So if you're pressing Z here, that would be the same as pressing 7 on the keyboard. So for example, I'm in some random view, I got confused, I got somewhere that I don't know where I am. If I press 7, I go to the perfect top view, which is a very convenient thing when you get confused in the projection of 3D space and 2D space that we have going on the screen now. Okay, so looking from the top view, let's add a couple of elements to the scene. So we can add, for example, going here to this tab here, which says add, we can say add light, and let's select the area light. So now you see the area light is here in the center of this thing. But let's move it. So we're going back here to the transform, and let's put it in the -20 by X, which should be fine. And let's call the rotation here -90 degrees. Or let's say 0. So it should be on a Y. It should be rotated with Y for 90 degrees or -90 degrees. Okay, now we have this light pointing towards the molecule. As you can see this line here. Let's scale up the light. Let's put it on 20 meters squared. And let's increase the power. Let's say it has 1000 watts. So what happens now to the scene? Or let's add another one. Let's select this light here. Let's press Shift D, and you can see when you move the cursor, it takes a duplicate of the selected object, and you can move it around. To drop the duplicate, you just click. And we don't want this light to be on this side. We want to have it on the opposite side. So let's say put it on 20, 0, 0. And let's have it rotate to the opposite direction, so 90. So now this area here, let's rename it and call it light left. And let's rename the other one, the one on the right, let's call it light right. So, okay, now let's go to the camera view by pressing 0. And let's change the viewport shading from this stock one to the rendered viewport shading. So we just need to click here. Okay, so I will press F11 and that will show the previous render result. So if we compare left and right, you can see in this part, particularly in this part of the image where we lost information, where the gold balls, it becomes blurry, it becomes confusing. We added more detail, and then it's easier to recognize certain things. Another trick that you can use to make stuff more readable in this confusing geometries is to change the light color. You change the light color again by selecting the light. Let's say light right first, and then you go to the tab, the light tab, which holds all of the properties of the light, and then you can go to color. So let's put it like a not very saturated blue color here. Sure, fine. And let's do the same for the left light, but let's put that one to red. And let's render this thing now. So here you can already see that we have a little bit more stuff going on in the shadows. It's quite interesting. Okay, So let's call that a job well done in terms of light. But we can still play around a little bit with the material of the gold. So in order to do that, we will just repeat the same thing as we did before. So again, we have this collection here, which is called gold. We go to gold, gold mesh, gold ball. And here, we can now change the material. I will make a bit more space again. So again, we will click use nodes. So now we're editing the material, which is called gold. And this change, this added this principled shader, which has all of the properties that we can adjust if we want to make something look photorealistic real. Okay, so gold is a color. Gold is a metal. So in principle, all of the materials in reality, as far as classical optics are concerned, are either a metallic or dielectric. So the main adjustments within this shader here are the base color, which we can set to whatever we like. Let's say that the gold is pink, for example. So the base color, the second slider is metallic. So now the metallic is at 0, which means the gold is a dielectric. If we put it to 1, gold becomes metallic. So the material becomes metallic. Even though it's possible to put values between 0 and 1, this is non-physical. So in principle, you either use 0 or 1 here. So let's put it to 1. And we have another important slider, which is the roughness. So if something is not very rough, it is very smooth. You can see how the gold atoms are now perfectly smooth. Or we can go into the other extreme and make them perfectly rough. So now they almost don't reflect light. But let's put it somewhere in the middle. So now we have a metallic nanoparticle of pink gold. And we can also render that. You can see there is a little bit of noise here. You have like this confusing patterns, confusing pixels, let's say. The way to overcome this problem is by doing the following. So if you're getting a noisy picture in general, you have to go to the image settings tab, and you have to go to sampling and then to render. And that is the number of passes that your computer does in order to average out the rays which are reflecting off the surface. So if you increase this to 200, the render will take longer, which maybe you will be able to notice here, but you will get slightly better quality. So if you have a very complicated object that you would like to render in high quality, then you would have to go with a lot of samples, and you would have to maybe commit more resources to this image. So let's call this fine, and let's save the image. So let's save it as NP as nanoparticle PNG. Okay, the convenient part of doing this, of rendering images like this, is that you have now access to basically 2 elements which are rendered under the same conditions, same lighting, same everything. And once you want to import them in a program to align, to make a composition of your images, they will work very well with each other. So that program can be Inkscape, it can be PowerPoint, it can be whatever you like. But for example, if we do it in Inkscape, now we have a molecule and a nanoparticle, which are basically very well matched in terms of their quality and the general style of their visual appearance. So This is a quite convenient thing to do. What did I want to say? So okay, so now we have imported the nanoparticle. Let's remove the nanoparticle now from the scene. And so let's again select this gold nanoparticle XYZ, and let's say delete hierarchy. And let's save the Blender file again by going to save, Control S. So now we have this container. This scene is now updated to have the left and right red and blue light. So let's open it again to show you one more trick, and that will be it for the first part of the session. So again, now we have if we go to the top view, you can see you have the perfect scene to just, the only thing you need to do once you open this Blender file is to import the molecule and press F12 to get the image. So let's do that again. Let's import a PDB. Let's go for this molecule PDB. One thing, before I press import PDB, let's just take a look at one thing. So if we look at this image that we rendered before, you can see that you have these lines. The sticks in the image don't look very smooth. The way that you can control this, as well as many other things, is in this import PDB window. So there are a couple of changes that you can make. One of them is to change the number of sectors in the PDB. You can put it to, let's say, 60. And you can maybe put the radius to be even smaller, let's say 0.05. There are many other settings. You can also check here to draw double bonds or triple bonds. And once you click here, you'll see you are back to the molecule that we had in the beginning. The thing is that inside of the Blender file, you cannot store data which is used to scale the atoms. So basically, every time you import a PDB, you would need to go through the process of changing the scale of the size of the atoms. So this would be, I think this is all of the information that you need to have in order to make very fast, quite beautiful images of molecules. So actually, the last thing we can do is to see how much time we need to go from a protein database file to a rendered image of a molecule. So let's call it now. So opening Blender, we have a protein database file. Blender opens file. Let's open the scene that we already set up. We have the scene. We say file import protein database. We import the molecule, rotate around X by 90 degrees. And now we just need to change the size of the carbons, 0.5, 0.5, 0.5. Press F12. Wait for the render, and then just save. And so image, save as. Molecule, save as image, and that's it. So it took us 50 seconds to go from protein database to rendered molecule, which is of high enough quality to be used in a table of contents graphics or covers and things like this. So in principle, this would conclude the first part.